Hey guys, how are you doing? Today we're going to solve a singular linked list problem. That is, we have to remove the nth node from the end of the list. So in the singular linked list, you have the reference to the next node, which means that you can traverse from the first node to last node, but you cannot traverse from the last node to locate the previous node. So the reference is not available. So how do we actually locate the node which we want to delete? So in this video, we're going to see two methods. The first one is toPass method, which is we want to traverse the linked list twice. One is to find the length of the linked list, and the second traversal is to actually locate the node, which we are going to delete. So let's see how do we code this. So I'll create a function, method one, which accepts head. Then I'll have a base cases here, like if head is equal to null or head.next is null and n is equal to 1, which means either the empty list or the list with just one node and n equal to 1. So that case we have covered with this single statement. We're going to locate the node which is actually before the deleting node because we need the reference, right? We shouldn't be reaching the deleting node. Instead, we'll be reaching the node which is previous to the deleting node, right? In order to traverse appropriately, I will create a node called first, which is a new node, and that will be located before head, right? So first is -1, and the next node of the first is head, right? Let's find the length. Let length equal to 0, t equal to head, well t length plus plus t dot next. After finding the length, we need to traverse again. So for I equal to 0, I is less than, till we reach the length minus n, right? Which means that n equal to 2 here. So length would be 5. So 5 minus 2 is 3. So we need to reach this node, this particular node, right? So from the previous node, I'll say next, that is 1, and I'll say next again, that is 2, and next again, 3. So if we are pointing to the head node, we can reach this node, but we want to reach this previous node in order to delete, right? That's the reason I've created the first node here. So now we can just say r plus plus and first equal to first, not next. We're just moving the first dummy node till we reach this node, that is the previous node of the deleting node, right? And once we got that, if first dot next, if that node is valid, if it is a head node, we have to check whether that node is a head node because the first did not move. Assume that the n is equal to 5, then 5 minus 5 is 0. So this will not happen at all. So first will not move. So if it is already head, then it's clear that they're asking to delete the head node. So we can just say head equal to head dot next. I'll return that head. If not, then first dot next equal to first dot next dot next. Return the head, right? So let's execute this. Method one of head. I think yes, we need to return here. Yeah. So let's see how do we solve using the one pass method. So we will avoid this length finding basically, right? So let's create one more method, function method 2, which accepts a head. So for the space sake, maybe, yeah. So let's take this example. We need to create two pointers which will point to a new node which will be created, and that node will be the previous of the head node. All right. So in order to make the traverse easier, and we have to ensure the corner cases are covered. So as a second step, we need to move the second pointer up to n, which will be located here. And as a third step, we need to move these two pointers till the second pointer reaches the last node, which is together. So if we reach the last node, then by the difference, the first pointer will automatically point to the node which is previous to the deleting node. Once we locate this node which is previous of the deleting node, it's very easy to disconnect the node and point to the next node of the deleting node. Let's see how do we code this. I'll write the same base case here. If head equals to null or head.next equals to null and n is 1, return null. Let's create the first node, which will be the previous of the head node. This node is -1 and first dot next equal to head. And let's create the second node. It also points to this new node, right? So let's move the second pointer up to n. So for I with I equals to 0, I is less than n, I plus plus, second equal to second dot next. We have to take care of a case here where if we move the second node up to n, if n exceeds the last node, for example, then it is not actually pointing to a valid node, right? So if the second dot next is not there, then return the head. So we don't need to delete any node. Second equal to second dot next. And the third step is to move both the nodes until we reach the last node, which will be pointed by the second pointer. So while second dot next, so first equal to first dot next, and second equal to second dot next. So once we locate the node which is previous of the deleting node, then we need to follow the same steps as in the first method. If first dot next is equal to head, then head equal to head dot next, return that head. Else first dot next equal to first dot next, right? So by this we can delete it and return the head. So let's test the method 2. Let's submit. Let's try to submit this. Alright guys, thanks for watching and don't forget to like and subscribe. Cheers.